topics. Up to now, I discussed about 2 topics. So, what are they? The first one is actually the heading of this class. In this class, I am going to discuss about classification of signals. Basically, the signals are classified into continuous time signals and discrete time signals. Again, these continuous time signals and discrete time signals are classified into deterministic signals and non-deterministic signals. And the next one is this one, periodic and aperiodic signals. And next, even and odd signals, energy and power signals, causal and non-causal signals, and real and imaginary signals. So in all these, up to now, we had seen for deterministic and random or deterministic and non-deterministic signals. Okay, so I explained about those 2 signals. Now I am coming to periodic and aperiodic signals. Periodic and aperiodic signals. So, or we can call it as periodic and non-periodic signals also. Okay, so in generally they will call it as periodic and aperiodic signals. So these are also one of the classification of signals. I will explain this classification also with respect to both continuous time and discrete time. I will give the more examples in the graphical way so for your better understanding. At the end, we will get the more examples, graphical representation of these periodic and aperiodic signals. Okay, there we can get the clear idea. So I will give that examples with respect to both continuous time and discrete time also. Okay, now I will go with the periodic signals. Periodic signals. So first, which signals are called as periodic signals? Periodic, period. I think all of you know the time period. What is the time period? Time period. So the time taken to complete one full cycle is nothing but a time period. Okay, now? So from there, I had taken the concept of period. Okay, so from there they got the periodic signals. They got the term periodic signals. First, I will explain what is periodic signals. Now, what is a periodic signal? A signal which repeats itself. A signal which repeats itself after a specific interval of time, or a signal which repeats itself at regular intervals of time. You can say anything. Okay, a signal which repeats itself after a specific interval of time. If after a specific interval of time, after some time, if the signal repeats the same signal what the previously presented, so it repeats. After some time, again it is repeating. So at regular intervals of time, it is repeating the same signal. Then the type of signal is called as periodic signal. So after one period, it is repeating. After another period, it is repeating. Simple. A signal which repeats itself. A signal which repeats itself after a specific interval of time. A signal which repeats itself after a specific interval of time is nothing but periodic signal. Or simply, a signal which repeats itself at regular intervals of time is nothing but periodic signal. Or I can explain this periodic signal with the help of a mathematical equation also. So, for any better understanding, if you go with the mathematical equations, then we can easily understand the concept, and we have more confidence in that concept if we explain that mathematically. It is easy to understand, and it is give more confidence that this is the way how the signal will be represented. It's the way how the signal. So a signal is said to be another definition for periodic signal in the form of mathematical equation. A signal is said to be periodic. A signal is said to be periodic if it satisfies the condition. If it satisfies the condition, x of t equal to x of small t plus capital T. I will say what is small t. You all know the small t is an independent variable with respect to time. That is a time variable. Okay, independent variable. And the capital T, that capital T is important. Here the capital T is the fundamental period, fundamental time period, because the periodic signals are based on the time period. Here the capital T will give the fundamental time period. So here what is the definition for a periodic signal with respect to the mathematical equation is if the signal satisfies the condition x of small t equal to x of small t plus capital T for all small t, then that signal is said to be a periodic signal. So here small t is the time and capital T is the fundamental time period. The smallest value that satisfies the smallest value of capital T that satisfies the above equation is called the fundamental time period, fundamental period. So here the smallest value of the capital T that satisfies the above equation is nothing but the fundamental time period. So I will explain what is the smallest value. Okay, now a simple example. Let us take x of t is a signal that will be equal to x of t plus some phi. So x of t is same as x of t plus phi. Let us think x of t is same as x of t plus 5. X of t plus 5. Next, x of t plus 10, x of t plus 15, is so on. So here the smallest value of t, which satisfies the above condition, is nothing but the fundamental time period. Okay, now so here the capital T is the fundamental time period, and we all know the relation between the time period and frequency. Both are inversely proportional to each other. The frequency and time periods are inversely proportional to each other. So f, the fundamental frequency, which is equal to 1 by time period, or 1 by time period is nothing but the frequency, that is the fundamental frequency of the signal. So if you know the signal, if you know the time period, automatically we can find out the frequency of that signal. So with how much frequency the signal is moving, we can find out if we know the time period, because f equal to 1 by t. Or if you know the frequency of the signal, so I can say the time period of that signal also, because t equal to 1 by f. So in either way, because frequency and time period are inversely proportional to each other. Now, periodic signal. So periodic signals, a signal which repeats itself after a specific interval of time. A signal which repeats itself after a specific interval of time is nothing but periodic signal. So let's take the example. Simple. Signal. Let us take, I am considering a signal like this. This is my signal. So this is 0 and this is some t. After the time interval, it is repeating again the same way. Here 0, it goes upside, 0, 0, down, 0, 0. This is t, and again this is also t. So from here, this is t, from here also it is t. From here it will be 2t. Again. Okay. So 3t. You can say this is signal as a periodic signal, because this signal is repeating after a specific interval of time. So this is the interval of time. After this it is repeating. It is t. Again it is also repeating t. So this is continuous. It will move on. So like to infinity. Okay. So here t, 2t, 3t. The smallest value is t. That is the fundamental time period of this signal. Or mathematically we can say that a signal is said to be periodic if it must and should satisfy the condition x of small t will be equal to x of small t plus capital T for all small t. Okay. So where t is the fundamental time period, so 1 by t, the inversion of the time period is frequency, that is the fundamental frequency. Okay. Now periodic signals. See, t, x of t represents the continuous time signal. If the signal is a discrete time signal, then also we can say a periodic signal like this. A sequence x of n is said to be periodic. A sequence x of n is said to be periodic if it satisfies the condition. X of n equal to x of small n plus capital N for all n. Okay, na? Say this is the fundamental period. So I will show that in the example. Okay, now. So this n will be here. I will show it how the n will be in this diagram. Now same there for the continuous time signals. If x of small t equal to x of small t plus capital T for all small t, then that signal is said to be a periodic signal. In the same way, for discrete sequences also, if x of small n is equal to x of small n plus capital N, x of small n plus capital N, x of small n plus capital N for all n, those signals are also called as periodic signals. Simple. Now a sequence x of n is said to be periodic with the period n. If I want to say this sequence is periodic sequence with a period n, then it must and should satisfy the equation x of small n equal to x of small n plus capital N for all small n. Now coming to the example. So this is one discrete. Let us take here on x axis we have the small n, and on y axis we have x of n. Okay. Now see, this signal also repeating. Let us consider from this level, from this point, this, next, this one. Consider this 5. Okay, now before also we have the same pattern. Larger one, larger, smaller one, below. Same pattern. Come to this one. This is a pattern. See, this is a pattern, and this is the pattern. So that pattern, that sequence is repeating at a regular interval. So this sequence, for this sequence I had given the value as capital N. Hence, if x of small n is equal to x of small n plus capital N, there I represented with capital T. Here they are represented with capital N. That's the only difference for continuous and discrete signals. Simple. Here, if you see this waveform, so the waveform is repeating from this point to this point. This point is again the same waveform. So for that reason, they are given from this value to this value, that is period T, which is equal to 1 by f. In the same way, it is repeating. Hence, they are given the value as capital N. So here the period, we can measure the period in this way also. Let us consider from this value to this value. This is also same T. So the distance from this point to this point is same as distance from this point to this point. So you can measure in this way also the time period. So this way is also right, and this way is. So there are two different ways to measure. Which one is easier? You can go with that one. So this is the time period, and this is also the time period. So you can go for anything. Next. See. Periodic signals. Simple. In the previous slide I said which repeats itself at a specific interval of time. Which does not repeat itself after a specific interval of time. Which does not repeat at regular intervals of time, those signals are called as aperiodic or non-periodic signals. So the signals which does not repeat itself at a specific interval of time. A signal which does not repeat itself at regular intervals of time. So it does not repeat. So it is a different one. It is not repeating. The signal is not repeating after a specific interval of time. At regular intervals it is not repeating. Then the signal is called as a periodic signal. Or the signals which are not periodic may be called as aperiodic signals. Okay, the signals which are not periodic signals may be called as aperiodic signals. Or in a mathematical equation also I can say that a signal that does not satisfy the condition, x of small t equal to x of small t plus capital T for all small t is nothing but a periodic, which does not satisfy the equation, In the same way, for the discrete, it does not satisfy x of small n equal to x of small n plus capital N for all small n. Okay, simply we can say like this. That is, if x of t is not equal to x of small t plus capital T for continuous, for discrete, x of small n is not equal to x of small n plus capital N. So if this type of signals are called as aperiodic signals, this type of signals are called as aperiodic signals. Okay. Now see this one. So there is no repetition at a regular interval. Is there any repetition of the signal? Here the signal is like this. Here the signal is something different. See, there is no repetition of the signal. Here there is no repetition of the signal at some regular specific interval of time. These signals are called as aperiodic signals. These are the examples of aperiodic signals. Now see, these are continuous time signal examples. So I have given the examples with respect to continuous time signal. I can give the examples with respect to discrete also. Okay, so you will see that examples in the coming slides. Okay, so here there is no repetition at specific intervals of time. Hence, these two are the examples for non-periodic or aperiodic signals. Aperiodic signals. Let us go. So aperiodic signal. This signal is also an aperiodic signal. There is no repetition. There is no repetition at the interval of time. So this is a aperiodic signal also. So we can go for n number of examples. I had given the n number of examples there. Let us see. Okay. So graphical representation of first periodic signals. Graphical representation of periodic signals. So the best examples for periodic signals are sinusoidal signals, square signal, and sawtooth signals are the examples for periodic signal. So sinusoidal. So it is varying with respect to time period capital T. Or square wave. Square wave is also varying with respect to time period capital T. Or we go for sawtooth waveform also. You can go for sawtooth. You can go for sawtooth. Let us take sawtooth. It is also repeating after a specific interval of time. At a specific interval of time, the signal is repeating. So this signal we can call that as a periodic signal. So the examples are sine wave. So the example square wave, and I have also shown the sawtooth wave. These are the examples for periodic signals. Now coming to this one, graphical representation of aperiodic signals. So aperiodic. Already I have given some examples. Here the aperiodic is, it is not repeating. It is not repeating. See, step signal, ramp signal, impulse signal are the examples of aperiodic. So you can get the topics unit step function, unit ramp function, and unit impulse function in the coming classes. So just step, our general steps. How the step will look like? General step. See. This is how a general step is. The same signal. This is how a general step is. This is example for step signal. And this is example for ramp. It is varying like this. Ramp. So it is varying with both x and y axis ramp. So step signal or unit step signal u of t. They are represented ramp signal r of t. So there is no repetition. Is there any repetition at some regular interval? There is no repetition. Hence, these signals are called as aperiodic signals. The step signals, the ramp signals, the impulse signals are the examples of aperiodic signals. Next, graphical representation of periodic and aperiodic signals. Now I am going to graphical representation. Let us say, see this example. So this waveform is repeating. This waveform is repeating after this interval t naught. So from here to here, the shape is same. Again from here to here, the shape is same. Here to here also the shape is same. It is repeating. Hence this is an example for periodic. This is an example for periodic. So this is example for periodic signal. See, in the below signal. So these below signals, there is no repetition. There is no repetition of signal at any specific interval of time. It is randomly varying. Hence these signals are called as aperiodic signals. They are called as aperiodic signals. Generally this can be called deterministic signal or random signal. Okay, periodic and then aperiodic signals. Okay. Now graphical representation. See, same thing. There is some sequence. Again the sequence is repeating. Again the sequence, periodic signal. So there is no particular sequence. There is no repetition. Hence it is nothing but non-periodic. Okay. The final one. Say repetition is there, a periodic, there is no repetition. Actually, this slide is for you to identify which one is periodic and which one is aperiodic. So on seeing this, you can say that here the signal is repeating. So you can easily say this is a periodic signal. So there is no repetition of the signal. So on seeing this diagram, you can say this is an aperiodic signal. So for that reason, I put the last two slides for your reference. Which one is periodic and which one is aperiodic. So these are all continuous. You can go through with the digital also. If you go for digital signals, we can get the digital waveforms. We can get the digital waveforms like this. So let us take any periodic signal. Let us take. So this is example for periodic signal because up to this one shape, again the same shape is repeating. So this is example for periodic signal with respect to discrete time signal. In the same way, periodic. There is no repetition. There is no repetition. So we can say this is aperiodic with respect to discrete time signals. So I can give the examples with respect to continuous time and with respect to discrete. So for your better understanding, I have given the continuous time signals as examples for this periodic, and I will give the summary. I will give the summary up to now what I had explained today. Okay, in this class, first I started with the classification of signals. Classification of signals. This is the first topic what I start. Today's topic is classification of signals. How the signals are classified? Signals are classified into, first one, continuous time signal, and next one is discrete time signal. Continuous time signal and discrete time signal. Again, this continuous time signal and discrete time signals are divided into many ways. First thing, I will start with deterministic signal and non-deterministic signal. Okay, deterministic signal and non-deterministic signal. And next one is periodic signal and aperiodic signal. Okay, we have so many classifications. So in this class, I explained only these three. Okay, so after this periodic and aperiodic, we have even and odd signals, energy and power signals, causal and non-causal signals, real and imaginary. There are so many signals. So in this class, I explained first one, what is a continuous time signal and what is a discrete time signal, and how they are denoted or how they are represented, and I had given the graphical examples, graphical representations of continuous time signals and discrete time signals. After that, I explained what is a deterministic signal and what is non-deterministic signal, and I have given the graphical representations, the examples for this deterministic signals and non-deterministic signals with respect to continuous time signal and discrete time signal. And finally, I gone with what is the periodic signal and aperiodic signal. I had given the examples for periodic and aperiodic. I had given the graphical representations of all those things. So finally, where I stopped, we have to verify whether a signal is periodic or not. They will give a signal. So these problems will come in the exam, like they will give a problem a phi sin omega t, whether the signal is periodic or not. They ask you to find out. So how you have to find out whether the signal is periodic or not, that we will see in the next class. So this is today's class. Thank you one and all. Thank you.